All right, so guys, example number 4, like I said, this is going to be a more complicated type of problem. It's still a rational function, absolutely still a rational function. Why do you suppose I would say that this one's a little bit more complex, a little bit more involved, maybe a little bit more difficult? Yeah, because we're trying to say that that rational function is less than or equal to 3, not less than or equal to 0. And quite frankly, things, they go a whole lot nicer if and when we're less than or greater than 0. So our job is going to be to finagle this in a way such that we are comparing it to 0. Just like we did back here on this problem. First thing that we did on this problem is we moved the negative 4 over so we could compare and figure out, yeah, that entire left side is less than or equal to 0. Same thing here, same approach. We have a 3, we want to move it over to the other side. It's just things get a little bit more complicated when we have the fraction. So we have the 2x minus 7 over x minus 5, now minus 3. Now it is less than or equal to 0. So we've done that. So question for you, is this negative 3 currently over 1?
Yeah.
Yeah. And if we're about to subtract fractions, what do we have to have? Common what? We have to have common denominators, which means I have to multiply this denominator by x minus 5, which I can only do if I multiply the numerator also times x minus 5. So I'm going to change that to plus negative so I don't lose it. So what that does for us in the numerator is we have the 2x minus 7. And if I distribute my negative 3, we have minus 3x plus 15. And we do have common denominators, so I can combine them here. So cleaning this up, combining like terms, what's my numerator going to go to, please? 2x minus 3x is negative x. Negative 7 plus 15 is plus 8 over x minus 5, less than or equal to 0. So it took a couple of, I don't know, seconds, minute, I don't know, whatever it took. But now we're in a position to where we have a rational function that's less than or equal to 0. And from this moment, now this problem is just like the previous one. We just had to get it into a situation to where it was compared to 0. Now, I don't want to confuse you. There is absolutely a reason why we are pushing you to do it this way. But I do want to at least mention that if we tried to set things up, could we have been successful comparing it to 3 the entire time? Yes, we could have. It's going to make things at least 10 times more complicated. But it could be done. Again, there's a student second period who was saying, well, I was able to get this one figured out, and I left it compared to 3. And he's absolutely right. As we break away from the degree 1 numerator and denominator, it's going to just get exponentially more complicated. So as just that general rule, if and when you have to work with these, let's get it set to 0. I promise you, I'm not trying to lead you astray here or anything like that. I feel like I'm giving you good advice. Let's make sure that we set that equal to 0, or not equal, excuse me, but less than, greater than, whatever, to 0. It's worth the couple of steps of algebra that it's going to take to get there. All right, so like I said, from here, it's the same as previous problem. We need to go to work and find our critical numbers. So how do I find critical numbers here again? Yeah, we're going to look at the numerator, set that equal to 0. So if negative x plus 8 is equal to 0, I guess I can actually move the x over. X is going to be equal to 8. Is everybody in agreement there? Okay, denominator, if I say my words right. If x minus 5 is equal to 0 and I add the 5 over, x is equal to. Okay, so any other critical numbers that are hiding or anything like that, or is this it? That's it, right? This is all of them. So if we have critical numbers at 8 and 5, my number line is going to have 5 and 8. And we know that something is happening at each of those locations. We just don't know what it is quite yet. So our job is to figure this out. So we have our t-chart, xf of x. And again, the non-negotiables, we have to test 5 and 8. We have a lot of choice as to what goes in the other spots. Now, please understand that here, again, technically, we have a choice. We could go back and work with the original, but why? That's going to make things, again, more complicated. So we've done this work to simplify, to set things to 0. So for that purpose, I'd say let's continue working with this negative x plus 8 over x minus 5, saying that we're trying to be less than or equal to 0. So this is, when we're plugging in our values, this is what we're going to be testing into. Does that make sense? But I do want to, again, I feel like I owe it to you to give you all the options, to let you know I'm going to tell you what my opinion is the best option, but technically we have a choice as to where you know, which function, the simplified or the original, which one we plug back into. Go with the simplified. That'd be your better option. Now, we could pick anything we want that is less than 5. I would assume that a lot of us probably would pick 4. I'm going to pick 0, okay? Just because I think that's even easier. Anytime we could use 0, I'm probably going to opt to do that. Between 5 and 8, I chose 6. Greater than 8, probably just to be a little bit different, I chose 10. I'm sure that a lot of us would have picked 9. Can't stress it enough, though. If you pick 9, I pick 10, and someone else picked 15, we're all going to get the same answer, whether it's all of us say yes or all of us say no in terms of the shading. All right? When we plug in a 0, put a 0 in for x, 0 in for x, we're going to get negative 8/5. Remember, we're trying to compare as to whether or not this is less than or equal to 0. This a little bit. And what are you going to tell me? Negative 8/5. Is that less than or equal to 0? Yes, it is, which means that my shading, less than 5, absolutely, we're going to shade that. When I put a 5 in place, look in the denominator, what's going to happen? We're going to get a 0 in the denominator. I want to be clear that that is not a 0, what I just drew. This is undefined, no solution. So can we compare no solution to 0? Whether we're saying it's greater than, less than, or anything like that, the answer is no. That is not going to be included. It's undefined. It does not exist. So for that reason, that point at 5 is going to remain open. When I put a 6 in place, you guys good with me just telling you, I'm going to get a 2 back out. What do you think? Is 2 less than or equal to 0? No, it is not. So we're not going to shade in between the 2 points this time. When I plugged an 8 in place, I got 0. All right, got to pay attention to the sign. Is 0 less than or equal to 0? Yes, it is. So what does that mean we're going to do with the point on 8? Fill it in. Is that what I heard? Good. And then finally, when I plugged the 10 in place, I got negative 2/5. Is negative 2/5 less than or equal to 0? It is. So we're going to shade greater than 8, or to the right of 8. So remember, in terms of our answers, there's the first part. What about the rest? What are we going to say? What's my interval notation? Where am I coming from? Negative infinity until I get to 5. Included or not included? Not included, so parenthesis. And I'm going to pick right back up where? 8, which is included, to infinity. All right, guys, how do we feel about rational functions, what we're adding on today? All right. So we feel like we can find critical numbers, no problem. We feel like we understand how to use the testing intervals. We can graph them. We can do the interval notation. We got this? All right, so guys, your homework assignment, what we're going to be turning in tomorrow. Now, I'm about to pass out some other things that are not due tomorrow, but what is due tomorrow is this section 2.7. As you can see, there's only 7 questions. Some of you may have gotten a jump start on the 3 or 4 that you could have done last night, again, meaning the non-rational function. Some of you might even be done, because I feel like if you could have done yesterday's stuff, you could have figured out most of today's. But again, we've got these 7 problems. That's what we're going to be turning in tomorrow. Let me stop this video. We'll talk about the other things here.